So getting things started with data science overall. I don't want to kick this off with a bunch of fear, uncertainty, and doubt about gosh, data is doubled, tripled, and it's going to be a tsunami, and you better get ready. But there's a certain intrinsic value in looking at that and what the trends are, and accepting that things have changed dramatically in the past 3 years, in the past decade, dramatically from any time increment before. So some of the key trends I want to point out. This is a slide that actually Microsoft uses. And there's been a device explosion, so there's just more things that are connected all the time. So that goes directly to ubiquitous connection. So everything's connected to the net all the time. We're all interested in everything that people are doing when they're connected, what they're clicking on, what their decision process is, and then how they're using data. We've got social networks. And that's not just about social things. It's about business, and it's about the heartbeat of your brand. It's about how people make decisions. And social networking is critical and creates just loads of data. Sensor networks, intelligent cities. One of the initiatives that Microsoft is working on that we're involved with is called the City Next program in the public sector. And it's all around monitoring what is happening in all the devices in a city. Everything from the rail system to elevators to HVAC systems. All of that is all driven by sensor networks. Coming with all of this is what's happened on the hardware and technology infrastructure side. Storage is just dirt cheap now. And overall computing has gone basically into the basement in comparison to costs as it has been in the past. So I want to show a really good slide that's insightful around big data. We hear about big data, and I'm not a real big fan of that title or that being dubbed just big data is really misleading at times. But it's all about, sometimes it's about the volume, but is also about the velocity and the variety, and variability could be another V that's thrown in there. But if you look at this, you can see actually kind of small font across the bottom is really important stuff there because it's actually the dates. It's a timeline. So if you look back in the 80s and 90s, really all we had that created data in our environments was ERP and CRM data, and all those type of transactions are line of business type of systems. But as we moved into 2000 and that decade, Web 2.0 came out, and that's when we got all kinds of extra things, whether it be e-commerce or social networks, intelligent search and web logs, and all of those types of items started to lead to the data explosion that you've all heard about. But now we're at a place where the new term Internet of Things is becoming very commonplace. And if you haven't heard that, you probably have. But if you haven't, it's something to take note of, because the reality is that everything's connected, and everything is producing data that is connected. So anything from buyer behaviors to what's happening with what I was talking about with the City Next program as an example of all the sensors that are within a city. Overheard a gentleman talking in the back of the room who checked all the webcams for the traffic on the way in. And that's just a good example of the type of data and the variety of data, because that's video data. How do you pull intelligence out of that? How much storage does that take to persist and to process? So all of those things are all part of the Internet of Things, which is really exploding our data needs. The other thing that's interesting down at the bottom is the cost of storage. So for a gigabyte back in 1980, it was almost $200,000, and then today it's about 7 cents. So that's that whole pivot point, inflection point, whatever you want to say about this influx of data, our desire to persist everything because it's cheap to do it and cheap to compute it. But then we still run into these contentions because they leapfrog one another, and we want to store more data than we can process, or we don't have a good way to intelligently process and get value from it. So that's what I want to talk about today. This is kind of interesting. This is a tweet that I picked up. Josh Willis, he's actually a code committer for the Crunch project of Apache. And I couldn't find, I think this is original because I went to see if he pulled it from somewhere else, but he says a data scientist is a person who's better at statistics than a software engineer and better at software engineering than a statistician. So I just bring that up because you hear data scientists, data science, data scientists, that term thrown around, and it means different things to different people. And I'm here to tell you that it's going to continue to, because when I think about data science, I think about it as kind of like I had a supply chain management course in business school, and the prof said that a good forecast is not a number. A good forecast is a range. And data science, I think, is also a range. It means it's different skills, it's different tasks, it's different types of value that's drawn out of it, and different tools. So it's, to be a little bit philosophical, it's more of a journey than a destination. It's more of a pursuit than an accomplishment. Or for folks like Mark, who is a data scientist, it's more continuous than discrete. And but the thing I want to pass along to you guys is it's also, because of that, it's a culture. And that's what I encourage. If you leave my discussion or my talk this morning with nothing else, is that I want you to buy in on the idea that data science is a culture. And it's something that you have the ability to open the doors to educate, to facilitate, and encourage in your companies, or you have the ability to shut it down and really limit yourself. So if you adopt data science as a culture, the tools as well as the skills, then I think you can be wildly successful. I'm going to use some metaphors today. One of them is I'm going to talk about two chasms. And so as we go forward, I'm going to talk about where there are definitely pivot points or inflection points around analytics, and hopefully prepare you to bridge some of those or to make the jump. So Gartner, if you're a fan or not a fan, doesn't really matter. This is a really strong model to look at. I talked to Doug Laney back in 2012 when he was doing some of the research around this, and this is from a presentation he did in 2013. And this is nothing new. Gartner's a research firm. They just compile things that are happening and identify trends and try and draw insight out of it. But this is a really good way to look at analytics. And the reality is that every company has analytics. It's just at what maturity level is it? If you have a simple application that has line of business canned reports, you have analytics. But that's way down at the easy, low value corner of this graph. It's descriptive analytics. You're saying, what happened? Well, what we've been for the past decade and longer really striving for is actually diagnostic analytics. It's saying, why did it happen? That's the cliche slice and dice, the ability to have an enterprise data warehouse and to perhaps have OLAP cubes or other caching technologies and be able to visualize data and get value out of it. That's diagnostic analytics. But notice there's two more levels above that, and I want to group those into a common nomenclature is advanced analytics. And so advanced analytics is really the predictive and prescriptive. So predictive is where everybody's going to now. Lots of companies have it. Lots of people are doing it at some level, in some niche, in some department. Some person is doing it. They generally don't have a wide culture of and systems and skills to support predictive analytics across their business. And that's really where companies are trying to get to. That's probably why you're sitting here today. What will happen, and then the step above that, that is really a far reach from there for most organizations, is saying, how can we make things happen? That's prescriptive analytics. But all these build on one another. You can't just go to prescriptive analytics and say, how can we make something happen, if you don't know the likelihood of something happening. So that's where the critical piece that we're going to talk about after this session, where Mark talks about Azure ML and machine learning, is all around the advanced analytics.